In this video, we're going to look at the relationship between Pascal's triangle and binomial expansions. So on the screen in front of you, you can see a triangle. This is Pascal's triangle, and it is formed by adding the numbers above to form the terms underneath. So we start with 1, and then as you can see, the 2 in the middle there is formed by adding the numbers above. So we could carry this on obviously indefinitely forever. Okay, so we could have a 1 adds to a 1 and a 5 adds to 6, 5 and 10 are going to add to 15, 10 and 10 make a 20, and so on and so on and so on. And this is how we form Pascal's triangle. Now, there are some things to be aware of and to make note of. So first of all, we can use some notation to help us. So the terms, the lines, we call this when n is 0 and n is equal to 1 and n is equal to 2. So that's how we define which line we're on. We use n, okay, starting with n is 0. And so on the right of your screen, you can see the first few of those. So the one I just made, that's going to be n is 6. Now the positions across from the left are defined using r, okay? So for example, this 6 here is on the 6th line of Pascal's triangle. So we say that n is 6 and we write this in a double bracket. So we write the 6, the n on top, and it is the second one across. So the first one would have been 6, 0, and this is one across from that. We call this one 6, 1. So for example, this 15 here is still on the 6th line. We are 0, 1, 2, 3, 4. It's the 4th one. Okay, so that's going to be 6, 4. This 10 here, this is on the 5th row, and the 1 is 0, the 5 is 1, 2, 3. So this is 5, 3. All right. So that is how we can define them. Okay. A generic term is going to be on the nth line and has position R, NR. Okay. So what else can we say about Pascal's triangle? Well, there are a few other things to notice. First of all, it is absolutely symmetrical, right? So that means that, for example, 6, 1 is going to be exactly the same thing as 6, 5, right? Okay, there's 6, 1, there's 6, 5. They're both 6. Okay, so we have this symmetry that is going to go on throughout the triangle. Also, there is 7 terms in the 6th line. Look, 1, 2, 3, 4, 5, 6, 7. And there is always one more terms than in the line than n value, right? Okay, so in the 6th line, there's 7 terms. In the 5th line, when n is 5, there's going to be 6 terms. So these are all things that are useful to mention, and we'll come back to those a little bit later. So there is Pascal's triangle. Next thing we're going to do is we're going to look at some binomial expansions. So a binomial expansion is something in the form a plus b to the power of n. And it's a binomial because bi means 2. There are 2 values there, look, a and b. And in these examples, we're going to keep n as a positive integer value starting from 0. So what we're going to do is explore now what happens when we set n to be 0 perhaps, or n is 1 or 2 or 3, and we're going to compare that to Pascal's triangle in a moment. So in exactly the same way, then let's have a look at some of these expansions and what are they going to look like. So let's start with a plus b to the power of 0, so n is 0. So what does that look like? Well, anything to the power of 0 is just going to be 1. So that's it. There's nothing else to say. A plus b to the power of 1. Well, that's going to keep the expression the same, isn't it? Right? So this thing is just going to be an a plus a b. Right? Now, I'm going to explicitly write all of the coefficients down. So let's write that down there. Look. So we've got 1a and 1b. Now, if I expand a plus b all squared, so n is 2 in this case, we're going to have an a squared. We're also going to have a b squared, and we're also going to have 2 lots of ab. So let's continue my coefficients being in red. There we go. Okay, so that is going to be what happens when we expand that and we multiply all those brackets. You could have done that one using the FOIL method. Now, if we carry this on, it gets more complicated to do, and expanding it isn't the point of this video. I'm just going to give the answer as it comes. So this will have an a cubed in it. It's also going to have a b cubed in it. Now, as well as the a cubed and the b cubed, it's going to have some other things. It's going to have some a squared b's, and it's also going to have some a b squareds. And if you do this, you're going to have 1a cubed. You are going to have 3 a squared b's. We are going to have 3 ab squareds, and we're going to have 1 b cubed. So if I was to expand this, that is what it would look like. Okay, hopefully you are seeing the pattern as it comes out of these expansions. Right, let's move on and do the next one. So if I did a plus b to the power of 4, we're going to have an a to the power of 4, certainly. We're going to have a b to the power of 4, and we're also going to have some other things. Well, we're going to have some a to the 3 times b. We're also going to have some a squared b squareds. We're also going to have some a times b to the power of 3, and these are all going to be in my expansion. The coefficients, well, we're going to have 1 a to the power of 4. We're going to have 4 lots of a cubed b. I'm sure you can guess how many of these we're going to have. We're going to have 6 a squared b squareds. We're going to have 4 lots of a b to the power of 3, and we're going to have 1 lot of b to the power of 4. Okay, we could go on and on forever and ever and ever. I'm going to stop there, though, and we're going to talk about some patterns. So the thing that I'm really trying to get you to understand here, if we zoom out a minute, you should be able to see a link between Pascal's triangle and the coefficients in red that we have for each of these expressions. So look, for example, if we take the fourth line when n is 4, and we expand that, our coefficients are 1, 4, 6, 4, 1. If we have the fourth line of Pascal's triangle, we have 1, 4, 6, 4, 1. Okay, so we can get these coefficients directly from Pascal's triangle if we choose to. Other patterns that we can spot, well, if we look at the powers of a, they are decreasing. Look, a to the 4, a to the 3, a squared, a. And then there's a to the 0. No a's at all on the going down. The b's are going the other way, though. They are starting from the right. Okay, we've got b to the 4, b to the 3, and we're decreasing in that direction with the values of b. All of this stuff is very useful when we start looking at some examples of some binomial expansion questions. So I hope this video has explained the relationship we have between binomial expansions and Pascal's triangle.